hello everyone. Welcome to the video lecture series on advanced separation process. Myself, Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. In this lecture, we are going to discuss about RO membrane materials and various modules which are used in reverse osmosis. Then we'll discuss about the concentration polarization, advantages of reverse osmosis and various industrial applications for reverse osmosis. So let's start with reverse osmosis membrane material and module. Although reverse osmosis membrane have been formed and tested using large number of different material, cellulosic polymer material such as cellulose acetate and cellulose triacetate are mostly used for manufacturing of reverse osmosis membrane. However, polyamide and polyurea composite membrane typically have a higher water flux and salt rejection in reverse osmosis process. The chemical structure of cellulose triacetate and polyamide are given in this figure. Even they are able to withstand higher temperature and wider pH such from pH 4 to pH 11. But polyamide membrane tend to be a less chlorine resistant as compared to cellulose acetate membrane. Solute which are effectively excluded by the cellulose acetate membrane are such as NaCl, NaBr, CaCl2, Na2SO4, sucrose and tetraalkali ammonium salt. These all salts are rejected by the cellulose acetate membrane, or can say that reverse osmosis membrane. The major limitation of cellulose acetate membrane are that it can only be used in aqueous solution, and that is must be used below about 60 degree Celsius. So RO membrane are divided into two groups such as asymmetric membrane, or can say that skin membrane, and thin film composite membrane. Asymmetric membrane have thin such as 100 nanometer permeselective skin layer supported on more porous sublayer of the same polymer, and dense skin layer determine flux and selective of membrane, where porous sublayer act as a mechanical support for skin layer. The thin dense layer has ability to block the passage of quite small molecule. These membrane are usually prepared by the phase inversion method. Now let's discuss about second type of membrane, which is a thin film composite membrane. This membrane consists of thin polymeric barrier layer formed on one or more porous support layer, which is almost always a different polymer from a surface layer. Here also surface layer determines the flux, where the porous backing acts as a mechanical support. The barrier layer is extremely thin, thus the allowing high flux water. This membrane generally made by the interfacial polymerization, a process in which high porous membrane, usually polysulfone, is coated with the aqueous solution of polymer or monomer and react with cross-linking agent in non-aqueous solvent. Two composite membranes are now commercially available. The first of these is polyamide 300 membrane and polyether membrane, which is a spiral wound module from exhibit a water flux comparable to that cellulose acetate membrane, but with 98 to 98.5 rejection of NaCl at 400 psi, or considered 27 atmospheric pressure. More recently, Ft30 interfacially polymerized membrane made from the amphenylene diamine and trisinol chloride. These membranes are somewhat less sensitive to chlorine than polyamide 300 membrane, and single pass free water desalination can be achieved with this membrane. So you can see here the thin film composite membrane which has three layer. First layer which is a thin film layer, or can say that dense layer. Second which is a support layer for that dense layer, and second backing up layer for supporting with these two layers. First layer which used for the separation, where these two layers act as a support of this first layer. So this is all about reverse osmosis membrane material and module. Mostly the cellulose acetate is used for the reverse osmosis membrane, and mostly spiral wound module and hollow fiber module are used for the reverse osmosis membrane. So this is all about reverse osmosis membrane materials and module. Now let's discuss about the concentration polarization. Concentration polarization is a term used to describe accumulation of rejected solute at surface of membrane. The solute concentration at the membrane wall to be a much greater than that bulk feed solution as shown in this figure. Concentration polarization is one of the most important factors influencing the performance of membrane separation process. Prediction of solute concentration polarization is crucial for the designing reverse osmosis process, predicting that performance and especially for understanding surface fouling phenomena. We know that there are mainly two types of fouling, such as internal fouling and external fouling. This both fouling occurs due to the concentration polarization. The consequences of concentration polarization are solute transport may be increased, or film resistance to mass transfer in liquid at membrane surface may be significantly increased, or considerable decrease in flux may be a result, and fouling due to the solute or membrane interaction may be increased. So these all are reasons for the concentration polarization. So in concentration polarization, solute that are passed from the feed side is accumulate on feed side membrane surface, and or can say that wall of membrane surface at feed side. Due to this, actual permeate, or can say that actual particles that cannot pass from this membrane due to the this gel layer, or due to the concentration polarization. Concentration polarization, which means accumulation of the solute on the surface of membrane. Due to this, the actual particle, or can say that permeate, cannot pass from the membrane, and it's reduced effectiveness of membrane. So this is the zoom view of the cross section, or can say that pore of the membrane. When the solute block the pore, the concentration polarization result. So this is a real image of reverse osmosis spiral wound membrane module before the concentration polarization, and this is image for the reverse osmosis spiral wound membrane module after the concentration polarization. So concentration polarization is a disadvantage for the membrane separation processes. So this is all about the concentration polarization. Now let's discuss about various advantages of reverse osmosis. Reverse osmosis is most important process of desalination of brackish water or seawater. Reverse osmosis enjoys several advantages over the conventional separation process. Some of, since the RO is a pressure driven separation process, no energy intensive phase change or potential extensive solvent or absorbent are needed for the reverse osmosis. We know that in distillation we are require extra intensive energy for the phase change, where in liquid liquid extraction we are require solvent, and in absorption we need absorbent to absorb, where in reverse osmosis there is no requirement of intensive energy for the phase change or solvent or any absorbent for the separation process. Second advantage for reverse osmosis is that it is a simple to design and operate than many traditional separation process such as a distillation and liquid-liquid extraction. To design the distillation, we have to use various method where we can easily design the reverse osmosis plant. Third advantage, which is in reverse osmosis, simultaneously separation and concentration of both inorganic and organic compounds are possible using this process. Fourth advantage is that it can be combined with the conventional separation process such as a distillation to provide hybrid process. We can use reverse osmosis by replacing the condenser, and we can get the pure amount of vapor where azeotrope are formed. So we can use reverse osmosis as a hybrid process with existing distillation plant to get higher purity comparatively the simple distillation and other processes. So these all are various advantages of reverse osmosis. Now let's discuss about various the application for reverse osmosis. Reverse osmosis has also provided its potential as a downstream separation process in various food processing and biochemical industry. Other use of reverse osmosis include the removal of organic salt, silica, and deionized boiler feed water, removal of inorganic salt, phosphorus, and nitrogen compound in municipal waste water treatment, and also demineralize of seawater and brackish water in production of potable water. So mostly reverse osmosis used for the desalination of brackish water. It's also used for the natural color concentration, concentration of landfill leachate, concentration of fruit juice, concentration of digested sludge, and also used for dewaxing of lube oil and processing of crude oil feedstock. So these all are industrial applications for reverse osmosis. We will discuss in detail about this all application in next session. In this lecture, discuss about the reverse osmosis membrane material and module, concentration polarization, advantages of osmosis and industrial application for reverse osmosis. So mainly we have discussed about the reverse osmosis membrane materials such as cellulose acetate and cellulose triacetate. Then discuss about the various modules such as for the reverse osmosis mainly two types module are used, spiral bound and hollow fiber membrane module are used for this reverse osmosis process. Then discuss about the various membrane used for the reverse osmosis such as asymmetric membrane and thin film composite membrane are mostly used for the reverse osmosis membrane. Mostly thin film composition membrane are used for the reverse osmosis membrane, which give better effectiveness for reverse osmosis membrane. Then discuss about the concentration polarization, one of the biggest drawback of membrane separation process. Then discuss about the various advantages of reverse osmosis compared to the distillation and liquid extraction and absorption. Then give short overview on industrial application for reverse osmosis. So this is all about today's lecture. I am completing my lecture here. Thank you.